Okay, this is a introduction to polynomials. Polynomial is anything that is one or more constant or variable terms. So one or more variable, constant or variable terms. These terms can be combined by addition or subtraction. These terms can be combined by addition or subtraction. One thing that's important to note for polynomials is that exponents must be non-negative, so must be positive. They can't be negative. And they have to be integers, which means they can't be decimals or fractions. So we'll put on a note on the side, no decimals or fractions for the exponents. Sorry, I'm running out of room there. But the exponents have to be positive integers. They cannot be decimals or fractions. So polynomial is one or more constant or variable terms combined by addition or subtraction. Exponents have to be positive integers. So they have to be positive numbers and they cannot be decimals or fractions. Some more vocabulary is standard form. The standard form of a polynomial is the terms in ascending order. Wait, sorry, I got that wrong. It is not ascending order, it is descending order. The terms in descending order. Descending order of degree. The descending just means that it's going from the highest to the lowest, and it's based on, for a polynomial, it's based on the degree. So it's the descending order of degree. We'll talk about degrees here in a second. Another key vocabulary term you're going to need is the leading coefficient. That is the coefficient. And the coefficient is just the number in front of a variable term. So the leading coefficient is the coefficient of the term with the highest degree. So the leading coefficient is the coefficient of the term with the highest degree. Okay, so we're going to use these things in order to classify polynomials by basically just saying what type of polynomial they are. By degree, if the highest degree they have is 0, which would be just like a number, that's going to be called constant. So that would be things like your numbers, 0, 1, 2, 3, 4, 5, -5, etc. Anything that doesn't have an exponent would be a constant. So this would be, for example, the number 5. If you have a degree of 1, this is called linear. So that is when you do have an exponent, but the exponent is 1. So for example, 5x. This variable has an exponent of 1. So 5x or 5x to the first power would be called linear. If you have a degree of 2, and again, that's the highest degree is a degree of 2, then it's going to be called quadratic. So that would be like 5x squared, 5x to the power of 2. Cubic is when you have a degree of 3, so things like 5x cubed. And for would be quartic. It's easy to get quadratic and quartic mixed up, but quartic is if you have a degree, or the highest exponent is 4. You can also classify them based off of the number of terms that there are. So if there's only one term, that would be called a monomial. If you have 2 terms, it's called a binomial. And if you have 3 terms, it's called a trinomial. Trinomial. All right, that's pretty simple, straightforward. Monomial, mono means 1. Binomial, bi means 2. Trinomial, tri means 3. So monomial, binomial, trinomial for 1, 2, and 3 terms. If you have 4 or more terms, so 4 plus terms, we're just going to call it a polynomial. Poly means many, so it's just many terms, polynomial. So here's some examples of polynomials. Things like x plus 8. X plus 8. This would be a linear binomial because the highest exponent we have is 1 on the x, and there are 2 terms, 1, 2. This is a linear binomial. Or you could have something like negative 5x squared. Negative 5x squared would be a quadratic monomial because it's a quadratic because the highest degree is 2, and it's a monomial because there's only 1 term. We could have something like 2/3 x to the 4th plus 9/10 x to the 3rd plus x squared minus x minus 3. So here, this would be a quartic. It's quartic because the highest degree is 4. And there are 1, 2, 3, 4, 5 terms. So we're just going to say this is a polynomial. If it has 4 terms or more, we're just going to say it's a polynomial. We can also have things that are involving more than one variable. So we could have something like x to the 4th. Actually, I'll do x squared y minus xy. I'm not going to have you classify any ones that are involving more than one variable because it can be a little bit trickier. But just know that things like this that involve more than one variable are still considered polynomials. We can even have things that are left to be calculated. So, for example, the square root of 81 plus x squared to the power of 3 is still a polynomial, even though it looks a little funky, because the square root of 81 is 9, and x squared to the power of 3 is x to the 6th. So this would be 9 plus x to the 6th. This would be a binomial because there's 2 terms, but because the exponent is 6, which is higher than the ones we know how to name, this is just going to be a 6-degree binomial. 6-degree binomial. Okay, before I move on, I'm going to show you some things that would not be considered polynomials. Those are when you have the square root of a variable that you cannot simplify. So the square root of x, you cannot simplify that any further. That would not be a polynomial. Or if you have x to the power of -2, that would not be a polynomial because you can't have a negative exponent. Up here we can't have a square root of a variable. Other things would be like a fraction exponent. So if we have something like x to the power of 3/2, that is not a polynomial. We can't have a fraction exponent. We also can't have things like 3 divided by x, or that could also be written as 3 divided by x. We cannot divide by a variable. We cannot divide by a variable. All of these things make it not a polynomial. So if you see any of those things later on, the classifying of it would be it's not a polynomial. Okay. So this is the notes part of this section. I want you to work on classifying the expressions below. So down here in the section in this table, you're going to put them in standard form, say the degree, the number of terms, and the leading coefficient. And then down below, you're going to be classifying these polynomials and then matching these polynomials to their classification. So you should have enough information now to finish this table and then do the next page. I'll bring it back up to the top so you can get any of the notes that you missed.